Hi everyone, I am Mohammed Aman Sheikh. I'm here to present my Scalable Cloud Programming project. My student ID is x23186925. The meaning of the project is to develop a scalable cloud programming solution using MPI, MapReduce, or Apache Spark. The data used in this project is visual data, a super visual data obtained from Lawrence Livermore National Labs. The log file structure of this data is as simple as this. Like it contains a column named as alert message flag, timestamp, date, node, date and time, node, message type, different component, level, message content. Now let's see, as a part of this project, which problems are addressed. So these are some of the problems addressed in this complete project. To find how many fatal log entries were there in month of December and January, which resulted in error, invalid or missing program image. Calculation of the hourly average of the L3 area RAM, which was detected and corrected. To find the top most frequently occurring deaths in the log. To find the largest number of app UNAV event node which generated it. And lastly, to find the earliest fatal kernel error where the message contains the last luster mount failed. Basically, to find a luster mount failed error and to find the earliest one of it. Now let's move to the environment setup and implementation part of this project. To implement this project and to study virtualization additionally, this project was completely set up on Ubuntu machine, which was set up on a WSL, that is the Windows subsystem for Linux. Firstly, Ubuntu machine was set up on WSL, and then all the dependencies, like all the packages like PySpark, Java JDK, Python 3 was installed. To start with, I installed Java runtime environment and Java JDK as a prerequisite to PySpark. So I have installed Java JDK version 11.0.23 and installed the PySpark version to implement a scalable programming and to address the big data questions. Additionally, I've also installed Jupyter Notebook book as a IDE. So we are using Jupyter Notebook IDE. So let's open the Jupyter Notebooks where our complete code and implementation is present. For that, let's change the directly to notebook folder that we created. Use the command Jupyter space notebook hyphen allow root and specify the port number on which we are serving the Jupyter notebook. We are using allow root as we are opening a Jupyter notebook using a root user. So let's enter the command. Now you can see the Jupyter notebook is serving, and you can see the complete code here. So the link for the Jupyter notebook is this one. So this is the Jupyter notebook and the code that I have implemented. Now let's start with with addressing each question and understanding the methodology and code for each. Like for the first question is to get the log entries in the month of December and January that resulted in an invalid or missing program image. For that, firstly I started the Spark station by importing the Spark station library from PySpark, which was installed earlier. It acts as an entry point to the programming with Spark that initializes the Spark. So here we have used the Spark station name as log analysis. I have specified the log file, that is bgl.log path. This file is present in the home directory with the scalable, like with the Python file. So we are directly specifying the file name, spark.read text. So we are using the Spark to read the complete data frame. As the data is really huge, it's a big data. So we are using a Spark to read the complete file. This is the regex pattern that I'm using. In here we can see I'm using the invalid or missing program image as a major filter that filters out the rows from complete data and stored into the pattern variable. I'm using a with column function that creates a new column with the name, data, date, time, message type, message content, and basically that extract the part of log lines in new columns based on a defined pattern, regex pattern. Further, I'm using PySpark SQL function that evaluates the query to obtain the required data that is from the month of December and January. So I'm using filter function along with different condition like fatal error and the invalid missing program images. And additionally, I'm specifying the month from which the data is to be fetched. And lastly, I'm printing the type to know about the type of this variable, and I'm printing the total count of the rows of that data frame. So we got to know with this that this variable was a data frame. So lastly, we are printing the rows of that data frame using the dot count, and we are getting the output as 18616. So this many log entries were there for the month of December and January with the error invalid or missing program image. The next question is to find the hour for each hour of the day, to find the average number of seconds during which the L3 EDRAM error was detected and corrected. Again, for this question, we are initializing the Spark session. We are inputting the log file, reading it, and using this pattern, we are finding the like particular pattern to fetch that log of a particular entry, and then we are applying the filters like EDRM values and detected and corrected to filter out that specific logs from the complete entries. Find the average, we are firstly grouping the complete data frame by R section, and then we are getting the then we are getting the average using the error count, and lastly we got the average in the variable average error duration df, and this is the average error count that we got, for which L3 EDRM RAM was redirected and corrected. The next question that we are going to address is to find the top 5 most frequently occurring dates in the log. So firstly, we are again initializing the Spark session and reading the content from the BGL log file. We created a basic regex pattern to filter out the content. Once the data is pre-processed and filtered, the particular data frame is extracted. We are using a group by and aggregation function to count the date for getting the count of occurrence of top most frequently dates in the log, and then we are ordering it by the count. The one with the highest count will be first, and the one with the minimum will be at the end. And we are printing the top 5 count using the show function. So on the date of close, and so on this date, uh, these are the top frequently occurring dates in the logs. The next question is to find the largest number of app UNE event, the node that generated it. So here we are again using the Spark session to start the Apache Spark session, and then import the BGL log file. This is the node pattern that we are using as a regex pattern to filter out the particular log from the complete data. So to implement the aggregation and to filter out the particular node and then to group by, we are using this function. So this function first groups the complete data by node, and then it counts the occurrence of each node and creates a column with the name event count, and then this complete data frame is ordered in a descending order based on the count variable, based on the count column. Now as we are using dot limit function and with the parameter 1, we are printing the topmost row of that table. So this is the node that uh, generated the largest number of app UNAV events. Next question is to find on a date and time which on which the earliest fatal kernel error where the masses contains Lustre mount failed. So this type of error indicates that there was an error with mounting the Lustre file system. This is the file system that is necessary for high performance to manage large volumes of data. So here again we are starting the Spark session. We are specifying the log file and then reading the complete file using the Spark library. Further we are filtering the complete data using the alert flag variable and the message Lustre mount failed, so that the particular log entries are filtered. Once the date time and timestamp is filtered out from the complete data, and a separate data frame DF filtered is created, we are ordering that complete data frame based on the date time, and we are storing the first entry in the variable earliest error, and then lastly we are printing that error with the error message and the log entry and the complete log entry. So we can see the earliest fatal kernel error date and time was this, that is on 3rd August 2005 with the timestamp this. So this was a project implemented by me for scalable cloud programming, in which we are using bgl.log file, and the complete project was set up on an Ubuntu virtual machine in using the WSL as a virtual interface, and we have used the Jupyter Lab as a IDE, and thanks a lot.